What's up, math scholars? Thanks for joining us for our video today. We're going to be going over 1 to 15 from the online practice test. So I've got the students in here. They've pulled the practice test up because we can practice clicking things. We can practice inputting answers and equations and drawing those graphs and plopping those stars, you know, all that fun stuff. So, hey guys, it's Friday. Who's excited? It's Friday and we have our air test on Monday. Yeah! Or Tuesday. They were kind of excited when I mentioned it was Friday, and then their enthusiasm dropped quickly when I said, the air is coming. They're smiling at least. Okay, so number 1, complete the first function table so that f of x is a function. To make sure you have a function, you want to make sure you do not have any repeating x values. So it's very important, whatever number you pick out of your head for this box, it has to be a number that is not a -1 or a 6. Make sense? And then this column, it really doesn't matter. These are y values. You can pick any number in the world for these. I don't even care. So maybe 10 and 2. Doesn't even matter. I don't think the computer would even grade that column. Complete the second table so that g of x is not a function. So something that would make it not a function is a repeating x value. Can somebody tell me what you put in that box? Yeah. That would work perfect. Sydney said she put a -1. If you put a 6, that would work perfect as well, because both of those would ruin the function. And then again, this y column does not matter whatsoever. Okay, there you go. That would be correct. Can I have somebody share what they put on number 2? Remember? You remember? Yeah, it is A. I think we did this as one of the practice packets, but the regression line would kind of go like this. It would hit at 1200, which would be at 0 miles from the center of the city. So rent in the center of the city. Number 3, I had tons of people coming to my desk asking about number 3, which is okay. I kind of said to them, look at that blue line in relationship to the black line. How is the blue line relate to the black line? How, if I would change the black line into the blue line, what would I do? And you would slide it up 3, correct? So to write g of x in terms of f of x, it's just f of x plus 3. And you would just type that into the box. Sound pretty good? All right. I don't know if you've noticed what I've noticed, but there were a ton of questions. There were a ton of questions on that practice air test that utilized the exponential growth equation. So jot that exponential growth equation down in some scrap paper somewhere. Thanks. I know oftentimes we tell you you don't need to memorize formulas. The formulas are provided to you. In this case, you flat out have to memorize this formula. There's no turning back. Write it on the card. Carry this card around you all weekend long, but you have to know this formula walking into the air test. So let's go over what all our variables mean. Can somebody tell me what that variable a would mean in an exponential growth equation? Yeah. The starting amount. Starting amount. Perfect. So in this case, I believe it is 270,000 bats. So that's going to be the first part of our equation. Y equals 270,000. Okay, what does B stand for in our exponential growth equation? Sandy? So yeah, it's called a growth factor, how much it is growing. Growth factor. Now the key is your growth factor, if it's bigger than 1, it causes growth. But if it's smaller than 1, it causes decay. So you just got to really be careful on what number you're putting in for your growth factor. Is your population of bats growing or shrinking? What's happening with our bats? Growing or shrinking? They're growing. So let's figure out our growth factor. You can put that in for B. The population of bats is starting at 270,000. We've got that. It's predicted to grow at an average annual rate of 2.9%. So you have to keep in mind that you'll have 100% of the bats that you have right now. You'll still have 100% of those bats next year. But you'll be adding an additional 2.9%. So that's 102.9%. We can't just stick 102.9 in for our growth factor. That would cause our bat population to grow way too fast. Anybody know what the growth factor would be? Or percentage? Has to be a decimal. Sandy?
1.029.
Perfect. 1.029. I do want you practicing typing that into the box right now, so you can practice using this exponent key. I believe this is the button you have to use to do exponents, unless you use the caret key on your keyboard. So report back if the caret key on your keyboard. It does? All right, and I want to show you a trick that I didn't want to show you yesterday, because I don't want you to cheat your way through practice tests. So when you're doing your practice test, I'm pretty sure some of you figured this out already. So let's say you type your equation, y equals 270,000 times 1.29?
Yeah.
To the x. I did use the caret key and it didn't work. That's awesome. See this little hamburger right here? You can click the hamburger and have you score the item right now. So bam, green check mark, you got it right. We kept that as secret because we didn't want you guys just doing green check mark every single question and cheating your way through it. But now that you know it, it'll help. Okay, so that finishes up that problem. All right, I think we're on our first problem that we would probably use Desmos on. So let's go ahead and click on our Desmos and graph this parabola. So click your calculator tool. Did you find this calculator tool be slightly annoying because you can't truly move it where you want to move it? You can only kind of move it left and right. You can't move it up and down. But the good news, at least it was good news for me, is when you hit the X and you close it out of your way and then you bring it back, it does remember what you had typed in. So I'm going to make my zoom a little smaller so you can see a little bit more. All right, you have to use y equals instead of x equals x squared plus 2x minus 3. It says use the add a tool point to show the x-intercepts and minimum or maximum of the function. So you're going to hover click your 3 places. You only need 3 places, you don't need 4, because there's 2 x-intercepts and 1 minimum point. This does not ask this question, but I'm going to ask this question. What is the minimum value of this parabola? What is the minimum value of this parabola? Do you know how to answer that question, Sydney?
Is it -4?
Perfect, yeah. So that comes up a lot. If they ever ask you for a minimum value, you give them a y value, okay, not an x value. So that's why Sydney answered it. Okay. But back to this problem, we're going to go ahead and use the add a point tool to plot 3 points, -3, 1, and -1, -4. So add a point. Let me scroll it. Let me. I have to walk over here. Add a point. -3, +1, and -1, -4. -3. -3, +1. +1, -1, -4. Bam. You only need 3. Sound good? Click your hamburger to see how it grades you. See if you got any of your points off. I see a bunch of green check marks. So the hamburger at the top will grade you. Still flopping our points. Oh, Sandy's got a green check mark. Once you have your 3 dots plopped, you can see those green check marks. If you forget where they go, just click your calculator again. -3, 0, 1, 0, -1, -4. All right, pretty good on this add a point question then. Let's move on to our finding the error question. So Fred is solving this equation. Do you guys remember where he messed up? He added this -42 and this 4 incorrectly. It should have been a -38 right here. So you can just say he made his mistake between step 1 and step 2. You don't need to do this again. And then if you'd resolve it out correctly, I kind of did it off the side. It'd be 24x 24x minus 56 equals negative 6x plus negative 38. So I solved it out, brought my 6 over, that was a 30x, brought my 56 over to this side, that was an 18, and got the final answer of 3/5. 3/5, that is the correct final. I won't make you type it in, that's not a question that'll automatically score, because it's just a paragraph answer. This year's air test won't have any questions that won't automatically be scored by a computer. They won't have any like paragraph type of answers, okay? So that was a change they made from last year's test to this year's test. Okay, did you guys find this problem frustrating?
Yeah.
I did. So frustrating. So I'm going to tell you the Devin Patel method. Anybody knows Devin Patel? He came up with what I thought was a great method of getting his line straight. I was just struggling with getting my line to go where I wanted it to go when I was doing this problem. So the very first part of it was not that bad. The y is greater than or equal to 5. I didn't think that was that bad because you could just draw straight across at 5. That was easy. But getting the diagonal line to go where I need to go, I really struggled with. So the Devin Patel method, and I just stumbled on it because I was looking at his computer screen. He did add points. And what he did is he put a point where the y-intercept was. Then he rose 2, ran 3, made a new point. Rose 2, ran 3, made a new point. Dropped down 2, ran over 3, made a new point. And he did this the whole way across his screen. And you know why he did that? So you could see where that straight line needed to go when he added it in. Okay, does that make sense? It was kind of like a guide. Having those points on the screen acted as a guide. Did you guys use that method or not? Oh, perfect. Then you were just as smart as Devin. I wasn't that smart. And then, since we're going to shade this horizontal line above and the diagonal line below, my green star would need to go somewhere in that region. And then I'm going to score myself and see how I did. Cross my fingers. Yay! They gave me a check. So I'll give you some time to play around with this until you can get the hamburger to give you a green check, okay? It just takes a little bit of practice until I get the lines really good about. Still live recording that video, aren't we? Put pause on the video. All right, we're on 8, and the class has told me yes, we can use Desmos. So go ahead, we're going to graph both of these, look for where they cross, and then those coordinates of the 2 intersection points will be our answer, okay? So I'll go ahead and pull down my Desmos, my calculator key, and type in these equations. So bam and bam. Went ahead and clicked twice, got 2, 4, 1, 1. You are allowed to have scrap paper out, so like if you can't remember those answers by the time you get over to type them in, just jot them down with your pencil. 2, 4, 1, 1 is what needs to go in the box, okay? And you can score that if you won. Pretty easy. All right, I remember this problem. Kind of was a little bit difficult to think through what they were talking about. We have this chart. It says that the data shows the number of states that use coal and power. And we want the percentage of states that use coal given the state does not use nuclear. I had to think about that a little bit. Given that a state does not use nuclear, that means this pink box here is true. And that's the data we're using. We're basically doing a study of 32 states. Does that make sense? Those are the states that do not use nuclear power. Now, of those states, how many use coal? 20. Very good. So you type this in your calculator. Let me grab my calculator. 20 divided by 32. You get 0.625. But in the box, they want you to input a percent. So you could be able to convert that easily, right? Move your decimal point over twice. What would I put in my box? 62.5, right? Number 10. All right, this one required a lot of work, but I'm not going to go through every single step and show you how to do every single thing in Desmos, but I'm going to talk about and refresh how to do things in Desmos. First of all, we have all this data. We have data on time. We have data on distance. You can crunch the numbers. You can get the mean of the time. You can get the mean of the distance. Okay, so to do mean in Desmos, you do mean, parenthesis, and you list your number. So 5, 6, all the way out till you get to 15. Does that make sense? You do the same exact thing down here in a second line for distance. So 1, 1.2, all the way out to 4.9. You can jot down what those answers are on your scrap paper. And if you need more scrap paper during the test, ask for more. You can have as much as you want. Now, this is what I want to chat with you about. You want to remove the outlier point from the data set. So if you look down distance, there's definitely an outlier. You see him? 11. Rather than just removing the 11, you have to actually remove the 10 as well. It's like these two go together. That's what an outlier point is. So I just went on my mean list and deleted out the 10 and went on my mean list for the distance and deleted out the 11. Okay? And that way you can kind of see what changes and what does not. So by doing that experimentation, I figured out that the mean of the distance changed, but the mean of the time did not. That was interesting. Did the same exact thing with median. You could just change these words to median, you know, with your Desmos. Found out that neither median changed. And then as far as range, the range of the time did not change because 10 was kind of in the middle, but taking that 11 out did change the range of the distance. So there's only 2 check marks on that whole list. A little surprising. All right, for this one, you can go ahead and kind of draw in where you think a regression line would go. It definitely has a y-intercept around 20, so that kind of eliminates choice A and choice C. You just kind of have to decide then, am I going to go with B or D? You can come up with 2 coordinates to help you decide. I think this coordinate is at 0, 20. This coordinate looks like it's at about, and I'm just estimating here, about, what do you guys think, 7.5, 30? And then you can just do a real quick like slope formula. So y minus y, 30 minus 20 would be 10. X minus x would be 7.5. And that slope, it's not exactly at 1, it's not exactly at 2, but I feel like it's closer to 2 than 1 probably. So B is the correct answer. So you just kind of do your best job at estimating the slope and the intercept of a regression line. This is the best work, sorry, erase that. 12, number 12. A linear model shows a relationship between grocery items and total cost, has a correlation coefficient of 0.97. We've kind of done some practice things with this. Reading through the choices, if you see the word causes, it's probably not going to be what you're going with. Purchasing more items wouldn't cause the higher cost. If a grocery bill has a higher cost, more items must have been purchased. There is no relationship or there is a strong relationship. So basically a correlation coefficient can just describe correlations and relationships between, but not necessarily causation. D. Y'all remember how to FOIL? First, outside, inside, last. Here we go. You can do rainbows or boxes. 2x squared times x is 2x cubed. 2x squared times 4 is 8x squared. 3x times x is 3x. And 3 times 4 is 12. 4 terms. None of those are like terms, so D. Can we use Desmos on this one? We've done this problem before, I feel like. The peaches grapefruit problem. Sure can use Desmos. So let's head to Desmos, type these in using x's and y's. Not b's and d's. 14. Cover click and there it is. So I basically found that Juan is selling 1.5 pounds of peaches and 1 pound of grapefruit. But you got to kind of remember the question. The question reads, what's the total number of peaches and grapefruit buys? So you need to add up those numbers. Add up 1.5 and 1. And 2.5. 2.5 is the answer to the 1 problem. All right, last one we're going to do today. Select all of the expressions that are equivalent. So we just have to do some foiling and some exploring here. Let's go ahead and foil out and explore our first choice. 3x squared minus y squared means I have to write it out twice. And I have to foil it out. I'll go ahead and tell you now, this is not going to be it. This times this will give me that 9x to the 4th, so it kind of feels like I'm on my way. But then things kind of turn south. This times this is negative 3x squared y. This times this is negative 3x squared y. And this times this is a positive y squared. So we have a number of problems. This is positive. It needs to be negative. And these two would add up to a negative 6x squared y. So that is not a good choice. Erase that. The second one, this squared here, will distribute over to the 3, making it a 9. These two squareds right here will multiply to become a 4, x to the 4th. And then that squared will be applied to the y. So that is one that we would check. So the second one you want to check. The third one you want to check as well. That x squared squared turns into a 9x to the 4th. And then the y squared is a y squared. That's perfect. This one is not perfect. Do you know what ruins it? The squared goes to the 9 and becomes an 81. So the minute I saw that that became an 81, you almost don't even need to finish it, because that's not going to be a good one. And let's foil out our last choice. That times that is 9x squared. That times that is negative 3x squared y. That times that is positive 3x squared y. And that times that is negative y squared. So those two add up to 0, which is awesome, because that is what we were looking for. So there are 3 check marks on this last problem. Okay. Well, thanks for watching the video, everyone at home. We're going to kind of shut it down now and just do a little bit of board buddies for like the last 12 minutes or how much time we've got. If I don't see you before the air test, good luck on the air test. I think you'll be fine. Just remember, please remember exponential growth. It appears so often for whatever reason. And you'll do great. Be a math scholar. Goodbye.